Okay, part 7 of the Fragger tutorial. We're going to set up collision with our tile map in this one, and we're also going to set up a mechanism for setting the keys for the different tanks. Okay, so a couple of things to do there. So let's have a look at the tile map collision first. Later on we'll have to do sprite collision, but tile map collision we'll do first. Right. In our level data, we have got these different tiles. The floor, which we're not going to check collision with. Bouncy walls, which obviously our tank doesn't want to go through. Soft walls that our tank doesn't want to go through. And absorbing walls that our tank doesn't want to go through. So we want to make sure that we stop our tank up against the walls. The sand is going to affect the speed of our movement, and we'll do that separately. Okay. Now, at the minute, we have got to remember that 0 is the floor, 1 is bouncy wall, 2 is soft wall, 3 is sand, and 4 is absorbing wall. Now, that's fine when we're doing these little maps, okay, because it keeps it nice and simple. But what I want to do, I want to create some constants to represent these different types of tiles. Okay, so I am going to create a new class that just contains some constants. Okay, and we're going to call that type. So let's go project add class. So project add class, chugga chugga chugga. It'll bring up that dialogue in a minute. I'll just pause my video so I don't waste my time. And I forgot to, no, it's come up now. I forgot to start my clock again, so I'll do that. I will remember one day to start my clock. I've got a little stopwatch because I can't go over about 24 minutes, otherwise it kills Cam Studio. Unfortunately, otherwise I'd do these videos for hours. No, I wouldn't. Right, anyway, back to this class. So we're going to create this type class. So type with a capital T. Okay, there it goes. Right, all we're going to put in this is some public constant. So I'm going to have public const int. So this is a little bit like our state class. Yeah, so in that, if I just flick to that, you can see I've got just constants with a number. So our type one, we're going to have floor equals 0. I think that was what it was. Level data, yeah, floor equals 0. Public const int bouncy wall equals 1. Public const int go back to level data. Soft wall was 2. Right, to quickly go back you can do Control Tab. That will flick, if I do it again, the last two. It works like Alt Tab does in Windows. So Control Tab will flip back. So Control Tab, soft wall. So soft wall equals 2. Control Tab. Next one was sand, that was 3. So public const int sand equals 3. And public const int Control Tab absorbing wall. Absorbing, use the same name, equals 4. So all we're doing is the tiles that we created in level data, we're giving them a meaningful name and using a constant to represent those numbers. When we create the maps, I could put, let's just swap it, I could put type dot absorbing wall, but it makes the map really look like naff. Alright, so we'll leave it as a 4. So use the numbers when you're making the map up, use the names when we're programming. Okay, so I've just created those. Right, let's go back to our tank and we're going to build our collision detection with the tiles. Right, we need to do this in the sprite. So we need to tell the sprite, when it gets updated by the game engine, check what tiles you're up against and take appropriate action. So to do that, in create tank, and again, if you're in you've gone to the tank subroutine and you're down at the bottom, like this. If you want to quickly find create tank, look for it in this list, in the picker, create tank, and it'll take you there. Right, in there we're going to say tank.onUpdate equals, that's what we're going to do, and we're going to say TileCollision, we're going to call it. We're just going to put that. Now, we can't get it to automatically create this because it doesn't understand what TileCollision needs to be. So we're going to have to manually create that. So I'm just going to create this subroutine underneath create tank. So I'm going to say void TileCollision, spelt exactly the same way. And in fact, I'm going to copy it and paste it to make sure I do. It's got one parameter, a sprite. Because what happens is the engine, when it updates the tank and draws it on screen and everything, it checks this update thing and says, oh, have you got any updates? Oh, you have. And it says, right, well, I'm going to run your subroutine. Here's your sprite. Okay, so that we can change things about the sprite if we want. Or look things up about the sprite. Updates are great for doing your own logic and things. The things that the game engine doesn't know you want to do. Okay, so we have to handle that logic ourselves. Right, all we're going to do in this TileCollision routine is say if we are up against a wall tile, align us against it if we've gone onto it. Okay, and we do that quite simply by saying assets dot active level dot map collision TileCollision align. Bit of a mouthful, that subroutine. I couldn't think of a more shorter way of naming it, to be honest. Right, so it wants to know what sprite I want to check. So this is going to be T, our sprite. Now, it wants to know which tiles we want to align up against. And we do that by specifying an array of tiles. And we're going to do it as a parameter really quickly. Okay, so we're going to say, I'm just doing this on the next line down, so I've just pressed enter after the comma, and I'm going to say new int brace. So remember, that means an array, put in square brackets. Then the brace allows me to specify them. So I'm going to say type dot, and it's all the wall ones. So we want absorbing wall, type dot bouncy wall, don't want to be able to go through that, and type dot soft wall. They're the only walls I've got defined so far. Okay, so I'm saying here's the list I want you to check against. There's a final parameter that we need to put in, and that's an offset. So that's an amount you can add on, okay, when it does the alignment. But we're not going to do anything with that, we're just going to leave that a note. Okay, right, theoretically that should just work. So let's just run that. So we've only actually added a little bit of code, okay, to check have we hit a tile, and if so, line me up. Now it's important that when you create your game, let's just put all the players on, when you create your game, you don't put your tanks on top of tiles that are walls. Anyway, so let's try it. Look, oh, the yellow and blue one have stopped. Remember, it jerks a bit because of the Cam Studio, so yours won't run jerky. Now I can't go through the walls, and if I, because I'm controlling the wall with the same keys, eventually they'll all end up on top of each other. Let's change the level because I had some different blocks in that. Start my game with one. Make sure. Yep, there you go. I cannot go through. You might get the odd glitch, especially if you make the speeds really high. Big problem with collision detection. High speed objects. Let's try and make sure the green one. And because we got this nice tank object, each one of those tanks has got access to that code. Okay? Excellent. That is awesome. Right, let's handle that sand. We want to go slower over the sand. Now the place to check for that is when we do our movement. Okay, so when we move the sprite, let's just see what tile we're on. Okay, and to do this, we get our direction vector. That's fine, we can do that. What we're going to do is we're going to find out what tile we're on top of. Okay, so in order to do that, we need to ask the level what tile is underneath our sprite, and that tile is a number. Remember, we know it's a number because we specified the level data as a set of numbers, okay, which we've now created constants for, so we can make our code look nicer. So back in our tank code, in our subroutine for move, we're just going to create a local variable, tile contents, and we're going to say, okay, Mr. Level, Mr. TileMap, what tile is underneath our tank? Okay, so it wants to know the location. So we need to ask the level, assets active level, what tile is at the center of our tank? Okay, let's just look at that. So we're saying get the tile contents, that's what get tile means, of the tile where the tank is centered. Okay, and that'll store that in there. What we then need to do is react to that. At the moment we've just got a normal floor, which we don't want to do anything for, that's just normal, or we've got sand, but you might have extra stuff later on. So what I'm going to do is a switch. So I'm going to say switch tile contents, and I'm going to say if those contents are type.sand, and this is where these constants make the program look a lot nicer, I'm going to alter this parameter's value. I'm going to say, okay, let's make the speed half as fast as normal. So I'm just going to say speed times equals 0.5f. Okay, so multiply it by a half. That is the same as writing speed equals speed times 0.5. Okay, just short form. So we're only going to affect the speed that's been given to us if we're on top of a sand tile. But we haven't got any sand tiles. Okay, so let's go back to my level data, and I'm going to alter part of my first level to include sand, which is a number 3. So I'm going to put a couple of 3s in here, just so I've got a patch of sand. Okay, right, let's just look at what we did again in tank. All we did, we said give me the tile at the center of our tank. That's what this little bit here did. And then we say, right, well, if it is matches up with sand, multiply the speed by half to make it half as big. Right, so let's run that and just see if that works. So you should see the sand on screen on my level 1, because that's what I did it to. Ooh, there you go, brilliant. The graphics are just so lifelike. I feel like I need a drink of water. Right, so if I go forward over that, I'm going at full tilt now, so this tank's like making my eyes bleed. Ah, it's like my granddad's driving it. Oh, back again. So let's just check one of the other tanks. So, oh, go on, go on, go on. He's catching me up. No, slow down. Oh, red one's getting away. Reverse over it. That'll be really slow. Look at that. Oh, the red one's catching it up. But as soon as we're on the grey, well, that is quite slow. As soon as we're on the grey, oh, back to normal. So you could make like treacle or something like that, which is super sticky, and you could go at an even slower speed across it. Okay, that's quite clever. Let's just have a look at what happens when the tank's on it. I still rotate fast, so I want to do the same thing really for the rotation. So let's go back to our tank code and move. Rotate for me is just below move, it's down here. I'm going to do exactly the same thing. Okay, So I'm going to copy this code, including the switch and its entire contents, and I'm going to grab all that. So I say when we rotate, let's do the same thing. But I'm not altering speed, I'm altering rotate speed. Okay, so doing not much, to be honest. I should slow down when I rotate, when I'm on sand. Okay, so that was just, let me just slowly do that again. I copied the tile code in move to see what tile I'm sat on, and I've copied it to rotate, but I changed the variable speed, the parameter, to rotate speed, because that's what it's called in rotate. Okay, get rid of that comment because it's a bit silly there now. Right, so we should have now set up collision detection with the wall tiles, collision detection with floor tiles, and an effect. So, play my game. I'm going to just use the red one. So, here's normal rotate speed. Let's go over there, and it rotates a lot slower. You might want to be pretty brutal on that and change that to make it even slower. Again, how you design your levels makes them either naff or interesting. Even with something as basic as this, you can make something good by designing the levels well. You know, not make it obvious and easy. Right, the final thing I want to do is I want to be able to wrap around my world. Okay. So if I go off the top of the screen, if there was a hole in my wall, which I'm going to put in a second, I want to be able to go off the screen. So let's just put a hole in my, so I'm destroying my level data now. I'm going to put a hole somewhere in the center. So I'm in my level data for level 1, and I'm just going to put a floor tile, and immediately below in the same column I'm going to put another couple of floor tiles. So let's just run that and see what my map looks like. So now I've got a gap in my map, and obviously I'm not collision detecting with the floor, so I could just drive off the screen. But what I want to do, when I go off the top, I want to come on at the bottom. He's gone now, I don't know where he's blooming gone. Oh, there he is. So I want to come on the other side of the screen. So let's have a look at how we can do that. So if we go back to tank, and we're going to go back to create tank. So let's look for create tank in this little drop down, create tank. And when we create the sprite, the engine can do all this work for us. Okay. You could do it all yourself manually if you wanted, if you were that way inclined. But what we're going to do is we're going to use the limit box system. So we're going to say tank.limit initialize. So we're going to activate it first, because it's by default it's turned off. And then we're going to say tank.limit dot, and we're going to set a region. We're going to say, going to specify a big rectangle, and the rectangle is the size of the world. Now the information for that is stored in the engine manager, world rectangle. Okay. If we just go back to level data to quickly have a look, scroll down to your draw level, you can see that the first line we set for each level was how big is the level. The ones we've got so far are just screen size, but we can have bigger ones, and you'll see that later on when we've got everything else working. We'll look at big levels. Okay, right, so that's where that information's coming from. So back to tank and our create tank subroutine. So we've got this world rectangle, so I'll just delete the comma and put it back in. It now wants to know, what do you want to do when you get to the edge of this rectangle? And if you press space, you'll get limit action come up. Press enter and dot, and you'll get all the different things. What we could do is bounce. Okay, that won't make any difference here because we're not using velocities, we're physically moving the tank ourselves. But we could do it for the bullets when we do those. We can kill our tank. as soon as we touch it, so you can set up like invisible barriers and things. But what we want to do is wrap. Okay, wrap exact. Close off the subroutine, call, put a semicolon. So that little bit of code will allow me to go off one side of the map, come on the other. Let's prove it, let's run it. And let's see if I don't get egg on my face. Oh, it is 10 o'clock at night and I've been up all day. Dedication for you. Right, start my game, driving my red tank. We've got to change the keys, but we'll do that in another video. Hey, there it goes, I'm going to reverse. This tank is reversing. You could do that, you could play that sound actually. Yeah. Could do that as a funny thing later on. Okay, so hey, there he goes. And he's off again, he's off back through. So you could use that as a little mechanism on your map. Okay. Right, finally, before we run out of time, let's go back to play game. We've got all the tanks using the same keys. Okay, that is pretty naff. Let's make a list of keys so that we can assign them to our tanks. In fact, no, I'm not going to do it now because I ain't going to run out of time. I'll do it on the next video. I might do it in the morning if I get time before I come to work. I can't record this at college. Pain in the neck. Too much noise, not enough equipment. Okay. You wouldn't believe the amount of equipment I got sat around me doing this. So I'll try and do that a little bit. It'll be a short video because it's not. That's all I'm going to show you, how to set all the multiple keys. Okay. Right, I'm ending it. That's it. We're done. We're done.